us quickly start exercise 7.1 with problem 1. In this problem 1, they have given pair of points and we need to find the distance between these given pair of points. See here, we have 2 points here on the screen. To find the distance between these 2 points, we are going to use the formula root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula we are going to use to find the distance between given points. Let us calculate distance between these 2 points using this formula. Here 2, 3 let us assume x1, y1, 4, 1 let us assume x2, y2. So if you substitute these values here in this formula, you can write 4 minus 2 in place of x2 minus x1. Similarly, in place of y2 minus y1, we will write 1 minus 3. Now, 4 minus 2 is nothing but 2 and 1 minus 3 is nothing but minus 2. 2 square is nothing but 4. Again, minus 2 whole square is also 4 only. So, after simplification, we will get 2 root 2. So, what is this 2 root 2? This is the distance between these two given points. Similarly, let us find the distance between these 2 points using root of x2 minus x1 whole square plus y2 minus y1 whole square. So let us compare this minus 5, 7 with x1, y1 and minus 1, 3 x2, y2. So in place of x2, let us write minus 1. In place of x1, let us write minus 5. So after substituting these values, we can write as shown here on the screen. Then after simplification, we will get 4 root 2 as the distance between these two given points. Now we have third bit in this first problem and we need to find the distance between these 2 points using this distance formula. So in place of x2, we will be putting minus a. In place of x1, we will be putting a. So when you substitute these values, we can write as shown here on the screen. After that, when you simplify, you will get the distance between these 2 points as 2 into root of a square plus b square. Let us now solve problem 2. In this problem 2, we have 2 questions. What are they? We have to find the distance between these 2 points and we should also find the distance between point A and point B, which is there here on the screen. To find the distance between given points, we are going to use this formula. What is that? Root of x2 minus x1 whole square plus y2 minus y1 whole square. So using this formula, we are going to find the distance between these 2 points. So in place of x2, we are going to put 36. In place of x1, 0. Similarly, y2 minus y1 is nothing but 15 minus 0. So these are the values we are going to substitute. After simplification, we will get 39 as our distance between these 2 points. Next, we have to find the distance between AB. To find that, we are going to subtract OB minus OA. So you will get 2 units as our distance between point A and point B. Now let us look at problem 3. In this problem, they have given 3 points. Let us assume this as point A, this as point B and this as point C. Now the question is, we need to check whether these 3 points are collinear or not. Now let us have a look at this problem 3 of exercise 7.1. In this problem, they have given 3 points and let us assume this point as A, this as B and this as point C. Now the question is whether these 3 points are collinear or not. Now you might be getting doubt, what do you mean by collinear? It's okay. See here, if point A, B, C are collinear, means lying on the same line, then it should obey the condition AB plus BC is equal to AC. AB plus BC should be equal to AC. If this condition is true, then we can say A, B, C. These 3 points are collinear. If AB plus BC is not equal to AC, then we can say these 3 points are not collinear. Let us now find lengths of AB, BC and CA using this distance formula. You know that what is the distance formula? Root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance formula. So using this, if you find distance of AB, you will get root 5. BC, you will get root of 212 and CA, you will get root of 265. Now if you add this AB plus BC means root 5 with root of 212, you will not get root 265. It means AB plus BC is not equal to CA. Hence these 3 points are not collinear. Let us now solve problem 4, and here 3 points they have given. So let us assume them as point A, B and C. Now the question is whether these 3 points will form a isosceles triangle or not. So now you might be getting doubt, what is isosceles triangle? See here, we have a triangle on the screen. If the length of AB is equal to the length of BC, then we can say this ABC triangle as a isosceles triangle. So now let us find the lengths of AB, BC and CA using this distance formula. These are the given 3 points. Now let us find length of AB using this distance formula, then BC, then CA. And when you look at AB and BC length, both of them are equal. It means these 3 points are forming an isosceles triangle. Hence we can say that these are the vertices of a isosceles triangle. Let us now solve problem 5. In this problem, there are 4 students sitting in a classroom, and after some time 2 students from outside come, who are they? Champa and Chameli. Then Champa says these 4 students are forming a square. That is what Champa says. Then Chameli says no. Now the question is whether these 4 points A, B, C, D form a square or not. This is the question. When you look at this closed figure ABCD, you can say this is a quadrilateral. Now you might be getting doubt, how can we prove this quadrilateral is a square? No problem. You have 2 conditions to prove. What are they? If all 4 sides are equal, one condition, and 2 diagonals of this quadrilateral are also equal, then we can say this ABCD quadrilateral as a square. So to prove that, now we are going to find the lengths of the sides AB, BC, CD, DA and the diagonals AC and BD. Now to calculate these lengths, we are going to use distance formula. What is that? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula we are going to use to calculate the lengths of sides and diagonals. So using this distance formula, now let us find distance of AB, distance of BC, distance of CD and distance of DA. When you look at these distances, all of them are having same length. Let us now find distance of diagonal AC and BD. Now when you look at these diagonals, they are also equal. Since sides and diagonals are equal, we can say this ABCD is a square and Champa was correct. Let us now solve problem 6. In this they have given 3 bits. So let us now take first bit. They have given 4 points and we are assuming this as point A, this as point B, this as point C, this as point D. Now the question is whether these 4 points will form square, rectangle or rhombus. So whatever it may be, first of all we need to find the lengths between these points using distance formula. So now AB distance we are finding, BC, CD, DA, and these four distances are equal now. So since four distances or four sides are equal, we can say that it may be either square or rhombus. So to confirm whether it is a square or rhombus, we need to find length of AC diagonal, BD diagonal. So now diagonals are also equal. So if sides and diagonals both are equal, then we can say this quadrilateral is a square. So for first bit, all the 4 points are forming a square. Now we are going to solve second and third bit of problem 6. So if you take second bit, 4 points they have given. Using this distance formula, now we are going to find the distance between AB, BC, CD and DA. When you look at this AB and BC, AB length is double of BC. From that what we can conclude is, since AB is equal to 2 into BC, these 3 points A, B, C are lying on a same line. Because of that reason, these 4 points cannot form a quadrilateral, but they will form only a 3 sides closed figure is nothing but triangle they will form. Instead of forming quadrilateral, these given 4 points will form triangle. Let us now solve third bit. As usual, using this distance formula, we are going to find AB length, BC length, CD length, DA length. When you look at this root 10 and root 10, you can say that AB is equal to CD. Similarly, root 18 is nothing but BC is equal to DA. From this, we can say opposite sides of the quadrilateral are equal. Let us now check the diagonals length. AC length we got 2, BD length we got 13 root 2. So they are not equal. So from this what we can say, opposite sides are equal but not diagonals. So this kind of quadrilateral is called parallelogram. So we can say these 4 points form a parallelogram. Now we are going to solve problem 7. In this problem, they are asking us to find the point on the x-axis. So this is x-axis. If the point is on x-axis, its y-coordinate is 0. So that is the reason we are assuming the required point P as x comma 0. Now they have given 2 other points, and these 2 points are equal distance from this point P. See here, from this point P, A has some distance. Whatever the PA length is there, same PB length is also equal. So from this given information, we can write AP is equal to BP. Using this given information, now we are going to find length of AP and BP using this distance formula. So AP length we got this much, BP length we got this much. Since they have given these two lengths, means AP is equal to BP, we can write this is equal to this. On squaring both sides, we can write as shown here on the screen. After removal of these brackets, and we can cancel x square and x square, 4, 4, finally we left with minus 4x plus 25 is equal to 4x plus 81. When you bring this 4x towards left side, you can write minus 8x is equal to minus 25 plus 81. Let us take this forward, and when you add these two, you will get plus 56. Finally x is equal to minus 7 we got. So now we can write the coordinates of the point which is equal distance from point A and point B, because we need x value. So finally we got the point, what is that, minus 7 comma 0 is a point which is equal distance from point A and from point B. Now let us solve problem 8. In this problem they have given 2 points, and distance between these 2 points they have given 10 units. Now using this information we have to find the value of y. Since they have given distance, we are going to find distance between these 2 points using this formula, and this is equal to 10 units. When you square on both sides, you can write as shown here on the screen. After that simplification, we will get y plus 3 whole square is equal to 36. Let us carry forward this. If we take square root on both sides, we can write as shown here on the screen. Then after transposing this plus 3 towards right side, we can write y is equals to plus or minus 6 minus 3. Now if y is equal to plus 6 minus 3, then we will get value 3, y value 3. If y is equals to minus 6 minus 3, then we will get value of y minus 9. So now we have two values for y. What are they? Plus 3 and minus 9. Let us have a look at problem 9. In this problem they have given 3 points, and they also give distance from Q to P is equal to Q to R. Using this given information, we need to find the values of x here, and we need to also find the length of QR and PR. Let's find the values of x using the given information. Now using this distance formula, let us find the length of QP and length of QR. Since these two are equal, we can write root of x square plus 25 is equal to 41. Then after squaring on both sides and simplification, we will get x is equal to plus or minus 4. So now we got the value of x. We are going to find the lengths of QR and PR. See here, just now we got the value of x. So using that we can write the coordinates of R, point R as 4, 6 and minus 4, 6. So using this, let us find the length of QR and PR. So when R is equal to 4, 6, then QR is equals to root 41, PR is equals to root 88. If R coordinates are minus 4, 6, then QR length is root 41 and PR length is root 162. Let us now solve last problem, that is 10th problem of this exercise 7.1. In this, they have given we have a point x comma y is equidistant from these 2 points. So let us assume this x comma y as point P, 3, 6 as point A, minus 3, 4 as point B. So as per given information, we can write PA is equal to PB. The question is, we need to find the relation between x and y, these x and y. For that, we have to find the distance of PA and distance of PB using distance formula. When we will find PA and PB, we get here. Now these two are equal as per given information, so that is what we are writing now. After squaring on both sides and using a minus b and a plus b whole square formulas, we can simplify as shown here. Let us take it forward. We can cancel x square here and here because both sides we have plus x square. Similarly, y square also we can cancel, and plus 9 and plus 9 we can cancel on both sides of this equal to symbol. Now we are left with minus 6x plus 36 minus 12y. This side 6x plus 16 minus 8y. When you take these right side terms towards left, you can change the symbol and write. Now minus 6 will give you minus 12x, 36 minus 16 will give you plus 20, minus 12y plus 8y will give you minus 4y. When you divide with minus 4 on both sides, you will get 3x plus y minus y is equal to 0. Now what is this? This is the relation between x and y. 3x minus y, y minus y is equal to 0. This is the relation between x and y. Hope you got good clarity on all the problems which we have discussed in this exercise 7.1. If yes, please share with as many friends as possible and don't forget to subscribe. Thanks for watching and learning. Have a nice day.